This is mixed exercise 11.03 and it's on integration, A-level pure maths, year 2. We've got 3 questions. Question 1. Find the value of the integral of 1 over 1 minus x squared between the limits of 0 and a half with respect to x. Giving your answer in a simplified form involving a single logarithm. Now you need to use partial fractions to solve this question. So first, we resolve this fraction into partial fractions. So I have 1 over 1 minus x squared is equal to 1 over 1 plus x times 1 minus x. So resolving this, we can write 1 over 1 plus x, 1 minus x is equal to a over 1 plus x plus b over 1 minus x. Then I'll multiply each of the 3 terms by the denominator of the left-hand side. So if I do that, I'm going to get 1 on the left-hand side equal to a times 1 minus x plus b times 1 plus x. Then if I let x is equals to 1, so when x equals to 1, I have 1 on the left-hand side. It should be equal to 2b, because if I put 1 here, all that becomes 0, and 0 times a will be 0. If I put 1 here, I get 1, plus 1, 2, so I get 2b, which implies that b is equals to the half. In the same way, when x is equals to minus 1, then I still have 1 on the left-hand side equals to 2a. Because if this is minus 1, all that becomes 2, and that becomes 0, which implies that a is equals to half. So the required partial fractions are as follows. 1 over 1 plus x, 1 minus x will be equals to 1 over 2 1 plus x plus 1 over 2 times 1 minus x. So my integral will be as follows. Integral of that with respect to x from 0 to half will be equal to the integral of all that with respect to x from 0 to half. I can write this as follows. Half integral of 1 over 1 plus x dx from 0 to half plus half integral of 1 over 1 minus x dx from 0 to half. Then if I integrate this, I'm going to get half ln 1 plus x. I put my limits in, minus half ln 1 minus x, and my limits goes in. This is negative because of the following. If I have the integral of 1 over 1 minus x dx, then if I let u equals to 1 minus x, then du equals to minus dx, which means that minus du equals to dx. And so the whole of this integral will be integral of 1 over u du, and there'll be a negative here because of this negative here. So I've replaced dx with minus du, so that will be minus du. And then the 1 minus x is replaced by u, this will be equal to minus ln u plus uc. And that's why we have a negative here. So proceeding from here, I'm going to do my substitution. So I'll put a half in here and 0 in there. And do the same for this term. If I do that, I'll get this. The integral of 1 over 1 minus x squared from 0 to a half dx is equal to half ln 3 over 2 minus ln 1. So I've just substituted the half and 0 here, minus half bracket ln half minus ln 1. Because if I put half in here, I get 1/2, and I put 0 in there, I get 1. Now let's simplify that. We're going to get half ln 3 on 2 minus half ln half, because ln1 is 0 and ln1 is 0. So I'm left with this. Proceeding from there, I'm going to factorize the half out. I'm going to factorize the half out. I'm going to get a half brackets ln 3 on 2 minus ln half. And using the laws of logs here, I can have a half ln brackets 3 over 2 divided by half. But this fraction here will reduce to 3. And so it means I have half ln 3. This can be written as, using the laws of logs, ln 3 to the power half. And this is ln square root of 3. And this is the final answer required. Question 2. Integrate the following with respect to x. A. Y is equal to x squared brackets 8 plus x cubed, all of that raised to the power 5. And B. Y is equal to x times e to the power 1 plus x squared. So for A, I have y is equal to x squared brackets 8 plus x cubed to the power 5. So if I integrate both sides with respect to x, I'm going to get integral of y dx equals to integral of x squared brackets 8 plus x cubed all to the power 5 dx. I'm going to use substitution here. And the substitution I'm going to use will be, let u equals to 8 plus x cubed. Then du will be equals to 3x squared dx. If I do 1/3 du, that will be equals to x squared dx. So now I can see that I can replace x squared dx with 1/3 du. And the 8 plus the x cubed will be replaced by u. So the whole integration can be written as integral of x squared brackets 8 plus x cubed to the power 5 with respect to x will be equals to 1/3 integral of u to the power 5 du. Because the x squared dx has been replaced by 1/3 du, is easy to integrate now. So if I integrate that, I'm going to get 1/3 times 1 over 6 u to the power 6 plus the integration constant. That becomes 1 over 18 u to the power 6 plus c. I can now replace the u with 8 plus x cubed. And if I do that, I'm going to get 1 over 18 brackets 8 plus x cubed, all of that to the power 6 plus c. And that is the answer required. For B, I have y is equals to x e to the power 1 plus x squared. So integral of y dx is equals to integral of x e to the power 1 plus x squared dx. I'm going to use substitution again. This time I will let u equals to 1 plus x squared. So du equals to 2x dx. And then half du equals to x dx. So now we can have integral of x e to the power 1 plus x squared dx is equals to half integral of e to the power u du. Because half du has replaced x dx, which is over there, and then the 1 plus x squared has been replaced by u, because we said u is equals to 1 plus x squared. And this now is very easy to integrate. I have half e to the power u plus c. If I replace the u with the substitution I made earlier, I'm going to get half e brackets 1 plus x squared plus c. And that is the final answer. Question 3. If y is equals to x cubed, evaluate the integral of y dx from 0 to 4 plus the integral of x dy from 0 to 64. So we are given that y is equals to x cubed. This implies that y to the power 1/3 is equals to x. So the integration we are required to do, which is this, will be equal to integral of x cubed dx from 0 to 4 plus integral of y to the power 1/3 dy from 0 to 64. We can now do our integration. If I integrate x to the power 3, I'm going to get 1/4 x to the power 4, and I put my limits in, plus. Then if I integrate y to the power 1/3 with respect to y, I'm going to get 3/4 y to the power 4/3, and with my limits of 0 and 64. Because if I add 1 to this, I get 4/3, and 1 divided by 4/3 is 3/4. So this is what I get. All I do now is put in my limits. So I'm going to get 1/4 brackets 4 to the power 4 minus 0 plus 3/4 brackets 64 to the power 4/3 minus 0. And this will become 4 cubed, because 1/4 times 4 to the power 4 is 4 cubed, plus 3/4 times 4 to the power 4. Because the cube root of 64 is 4, and we raise that to the power 4. So that's what we get. So I'll have 4 cubed plus 3 times 4 cubed, because this 4 will cancel one of the 4's over here. And then if I do my factorization here, I'm going to get 4 cubed brackets 1 plus 3, and that will be 4 to the power 4, because 1 plus 3 is 4. And finally, I get 256. And this is the final answer. And this brings us to the end of mixed exercise 11.3.